Hey guys, welcome. This is your host, Yuvraj. What lurks at the solar system's stormiest frontier? Neptune, the blue giant of impossible hues and supersonic winds. Billions of kilometers from home, the sun is a tiny, icy star. A year out here lasts 165 Earth years. Since its 1846 discovery, it completed its first full orbit only in 2011. Jet streams scream faster than sound. Storms rise and vanish. Today, 8 fast, mind-bending facts about this enigmatic ice giant. Buckle up, we're leaving home. Stay to the end for a brain-twisting surprise. Let's begin. Imagine discovering a world not with a telescope, but with math. That's the incredible story of Neptune. In the 1840s, astronomers noticed Uranus was veering off its predicted path. French mathematician Urbain Le Verrier calculated that an unseen eighth planet was the cause and predicted its exact location. On September 23, 1846, astronomers pointed their telescopes and found it. To this day, Neptune is the only planet found through mathematical prediction rather than direct observation. It's the 4th largest planet by diameter, but it's the densest of all the giant planets. Despite being smaller than Uranus, Neptune is more massive, 17 times the mass of Earth. This density points to a heavy core of rock, ice, and exotic materials under immense pressure, giving it a powerful gravitational pull. Neptune orbits our Sun at an average distance of 4.5 billion kilometers, or 30 times farther than Earth. Light from the Sun takes a lonely 4-hour journey to reach its cloud tops. This immense distance means a single year on Neptune is approximately 165 Earth years long. The planet was discovered in 1846. Neptune is so far from the Sun that it only completed its first full orbit since its discovery in 2011. From there, the Sun is just a tiny, bright star, providing only 1/900th of the sunlight we receive on Earth. The first thing that strikes you is its color. A stunning, deep azure blue. This comes from methane gas in its atmosphere, which absorbs red light and reflects blue. But Uranus has similar methane and looks paler, so scientists suspect another unknown ingredient gives Neptune its vivid hue. Beneath the gas is a slushy mantle of water, ammonia, and methane ices, surrounding a rocky core about the size of Earth. Welcome to the windiest planet in our solar system. Neptune is home to ferocious supersonic winds clocked at over 2,000 kilometers per hour, faster than the speed of sound on Earth. Its most famous storm was the Great Dark Spot, an Earth-sized vortex observed by Voyager 2. But unlike Jupiter's centuries-long storm, Neptune's are fleeting. By 1994, it had vanished completely. This incredible weather isn't powered by the distant sun, but by a powerful internal heat source, churning its atmosphere from within. Neptune also has a rebellious companion, its largest moon, Triton. It orbits backwards, a dead giveaway that it's an imposter, a captured object from the Kuiper Belt. It was a rogue world that wandered too close and was ensnared by Neptune's gravity. This violent capture would have wreaked havoc on Neptune's original moon system, and the tidal forces are still slowly causing Triton's orbit to decay. Millions of years from now, it will spiral too close and be torn apart, forming a spectacular ring system. But for now, Triton is one of the most geologically active worlds we know of. Despite its surface temperature being a frigid -235 degrees Celsius, Voyager 2 spotted active geysers erupting plumes of nitrogen gas and dark dust several kilometers into its thin atmosphere. This activity is likely powered by seasonal heating from the faint sun. Triton is a captured, backward, erupting ball of ice and rock, a testament to the chaotic and dynamic history of our solar system's outer edge. When you think of planetary rings, Saturn immediately comes to mind with its magnificent bright system. For a long time, we thought rings were rare. But we now know all the giant planets have them, and Neptune's are perhaps the strangest of all. They are so faint, dark, and tenuous that they were impossible to confirm from Earth for decades. They are more like dusty smudges than grand structures, composed of dark material, likely organic compounds processed by radiation. The discovery of these faint rings was a story of persistence. Ground-based observations in the 1980s hinted at their existence, showing that stars would sometimes blink out just before or after passing behind Neptune, but not always. This suggested the material wasn't in a uniform ring, but perhaps in incomplete arcs. It wasn't until Voyager 2's flyby in 1989 that the system was fully revealed. 5 faint rings, named after astronomers instrumental in Neptune's discovery. Gall-Leverrier atoms. The most bizarre feature is that the outermost ring, the Adams ring, contains several distinct brighter clumps of material called arcs. These arcs, with names like Liberté, Égalité, Fraternité, are a gravitational puzzle. Normally, material in a ring should spread out evenly. The fact that these clumps persist suggests they are being gravitationally corralled by a nearby small moon, Galatea, in a complex orbital resonance. Neptune's rings are a ghostly, clumpy, and delicate system, a subtle whisper compared to Saturn's shout. We've established that Neptune is cold, right? At its cloud tops, temperatures plunge to about 214 degrees. That's 353 degrees. It's one of the coldest places in the solar system, and yet it has a powerful internal heat source driving supersonic winds. This hot and cold paradox hints at extreme internal conditions. Deep below the frigid clouds lies a mantle that is not solid, not liquid, not gas. Something far more exotic. Scientists theorize a supersonic water ice mantle under immense pressure. In that state, water molecules break apart. Oxygen atoms lock into a solid crystal lattice. Hydrogen nuclei, protons, flow freely like a liquid. That bizarre, electrically conductive layer likely generates Neptune's strange magnetic field. A hot, churning, electrically charged interior. And that's Neptune in 5 minutes. A cold, blue, stormy world brimming with surprises. From its discovery through the power of pure reason to its supersonic winds, rebellious moon, bizarrely tilted magnetic heart. Neptune reminds us the edge of our solar system isn't quiet or forgotten. A frontier of extreme physics and cosmic wonders. It generates its own heat rages with storms faster than sound, holds a moon spiraling toward destruction. Every fact opens dozens of new questions. What is the unknown chemical behind its deep blue? What keeps its faint ring arcs from spreading? Understanding Neptune helps explain our solar system's formation and the thousands of Neptune-sized exoplanets we're finding. A local laboratory for a cosmic phenomenon. The universe needn't make sense to us, but with every mission, every calculation, every observation, we lift the veil a bit more. If you enjoyed this deep dive, like this video, subscribe, click the bell. Tell us in the comments which facts surprised you. Until next time, keep looking up.